हेलो दोस्तों, अब हम नेक्स्ट फार्मूला प्रूफ करेंगे। नेक्स्ट फार्मूला था इफ y इक्वल टू y is a function of composite function. If y is a composite function, then how we'll find the derivative of composite function? First off, we learned what do you mean by composite function. Composite function. Composite function. If y is a function of u and u is a function of x, then we can write y equal to gu, function of u, y equal to function of u, and u is the function of and u is the function of x. Then we can write g into function of x, y equal to, then y is called composite function. Y is called composite. And the rule used to find derivative of y is called chain rule. Just mind it, learn it, commit to memory it. This line. If y is a function of u and u is the function of x, then we can write y equal to gu. We have written u is the function of x. U is the function of, then y can be written as this. Y is called the composite function. The rule used to find derivative of y is called the chain rule. In this case, dy by dx, derivative y with respect to the x, where x is the variable of u, is equal to du by dy, dy by du into du by dx. This is the formula which is known as chain rule. Now we have to prove this. Have you understand this? Now आप लोग ने ये समझ लिए। देखिए क्या है कि कंपोजिट फंक्शन किसको कहते हैं। y is the function of u, u is the function of x, एक दूसरे से रिलेटेड है। Then we can write y equal to gu, y is the function of g represent the function, f represent the function. We can denote by any of the letters. Now u can be denoted as fx. Then we can write y equal to g function of fx. Then y is called the composite function. The rule used to find derivative of y is called the chain rule. What is chain rule? The derivative of y with respect to x x is the variable of function u. Then we can write derivative dy by dx equal to du by dy, it is dy by du into du by dx. Now come to the point of proof about the proof. Seventh, this is seventh chain rule. Chain rule. Proof. Let y equal to g fx is a composite function where u equal to function of x. Now let delta x comma delta y are the increment in x and y respectively. Then we can write y plus delta y equal to g into function of x plus delta x. Now rearrange it. What we want? Delta y by delta x. Keep here delta y in this side. We can write function of x plus delta x minus y. Or this can be written as g into function of x plus delta x minus y equal to now we want delta y by delta x. Therefore delta y divided by delta x, if we divide both sides, we can write g x plus delta x minus g function of x divided by delta x. Now taking limit both sides, as delta x tends to 0, what we get? I am erasing the arrow line. We will get limit delta x tends to 0, delta y by delta x equal to limit delta x tends to 0, g of function of x plus delta x minus function of x function of x divided by delta x. Now u equal to fx, then delta u is u plus delta u equal to x plus delta x. Delta u is the increment in u. If u is the function of x, if there is any increment in the variable delta x, corresponding increment will be there in the function u. That is, we can write delta u plus delta u equal to f function of x plus delta x. Now, if we put this value here, this is suppose equation number 1. If you write there, it is easy to state. Mention. Now I am erasing this line. For this part, we can write dy by dx equal to limit delta x tends to 0, g into u plus delta u. For this, we can write this, substitute this value, minus g into, for this we can write u divided by delta x. Delta x. Now we required what? In place of x, we required u, delta u here. For this, limit we can write delta x tends to 0, g into u plus delta u minus g into u divided by delta u into, we have added this additional point, we can add and divide by same delta u. Now there is x, delta x. As delta x tends to 0, delta u must be 0, tends to 0. Since there is an increment in x variable, there will be an increment in function. If there is no increment in the variable, then there will not be any increment in the function. Therefore, if delta x tends to 0, this must be tends to 0. We can write here delta u, limit. Now this is the limit of two functions, 1 or 2 we can assume. So we can write delta u tends to 0, g into u plus delta u minus g into u divided by delta u into limit, here delta x tends to 0, delta u by delta x we can write this. Now for this you can see here, this is what was equal to limit delta x tends to 0. This is the basic definition of derivative. Now for this term you compare with this. What we can write? Dy by u is the gu is the function of y, where u is the function of x. Now for this we can write dy by dx into, for this term we can write in this term for du, here u, the increment is u, or this, for this part we can write du by dx. Therefore dy by dx equal to this. This is the proof in case of composite function. This rule is known as chain rule in differentiation. And if we get the form of equation, form of the algebraic expression y equal to function of u into v function of g into function of x, in this type where x is the function of u, fx is the function of u is the function of x, where fx is the, where u equal to fx. Then we can use this formula. I think you have understood. Now commit to memory. आप इस फॉर्मूले को याद कर लेना और ये स्टेप बाय स्टेप आप जब 2-4 सवाल बनाओगे with the help of the principal method or by definition method, then you will understand in better way. Thank you. Next period में, in next period we will learn another formula, proof of another formula. Thank you.